Hello and welcome back. In this video we want to focus on exceptions and exception handling, and this is particularly important if we want to recover gracefully from situations where our program may not behave as we expected or where we suspect it might crash. So for example, when we receive an input from a user or from a different function that we do not expect, and now we need to react to this somehow, or we're not quite sure if an operation will succeed and we need to proceed with caution and react if it fails, or something else goes wrong and the program crashes, but we don't really want to just stop, but we want to recover gracefully. The simplest way to illustrate this is to have a division by 0, and we can use the print statement, print 1 divided by 0, and this will of course fail because the division by 0 is not defined, and this is exactly what we see, so we get a division by 0 error. And Python will also tell us where this error occurs, which obviously, because we only have written one line of code, it needs to be there, but we will have often a long piece of code, and then this traceback, as it's called, will allow us to debug where this occurs. Now, obviously, we knew beforehand that we shouldn't do this, and the program crashed when we did this. But we want to recover from such a situation more gracefully, and this is called what we do with exceptions. There are many predefined exceptions, and we can also define our own. And this not only helps the user to understand what's happening, but it also makes our code more resilient. In our case here, we get the special exception 0 division error with the edit explanation division by 0. And we now look a bit more behind the scenes what we can do with this. So if you want to recover from the situation more gracefully, we need to intercept these exceptions. So if you suspect the operation fails, we use the following construct. We have the try statement, which is a keyword in Python, followed by a colon, and then the indented block of the code that may or may not fail. And then we accept any of these exceptions that are being raised, and we can accept several of them, and we can have a list of very specific ones, and then we can handle each of them differently. You can also have the else and the finally statement. So for example, we could extend our code above, like we try print 1 divided by 0. Then we accept this specific exception, 0 division error, and label it as E. And then except of crashing, we make a print statement and say we shouldn't try to divide by 0 and record the following exception. Right, and this is what the code does. So here our program didn't crash, and we intercepted this error and handled it in a specific way, by just printing and then moving on. You could also then have several exceptions in one line and do the same error handling for each of them, or have it as before. Different exceptions have different ways of error handling. So this is where we handle the exceptions that are already raised, and the other part of this construct is to raise exceptions. So we may come to a point where we need to let the user know what the situation has occurred, but should not have occurred. In the simplest way, we could write a print statement and print out an error message and then maybe break out of the program. But it would be better to pass this exception upstream, for example, the code the user calls, or in a function or in a class, so that the user of our code can handle the error as they see fit, or they can let the program crash or handle it in a different way. To raise an exception, we use the keyword raise. Python has a list of predefined exceptions, which is quite comprehensive, and we can define our own as well. Now, for example, let's define a function that divides two integer numbers, and if the numbers are not integers, we raise an exception. So our function is myDivide a and b, and now we need to assume that a and b are integers. Remember that we can use the type function to determine the type of a variable, and because of the dynamic typing in Python, this function as such doesn't make any assumptions about the type of a and b. So if we just use it like this, it could be floats or strings. But dividing strings, for example, doesn't really make sense. So we only want to do it for integers, or maybe we could also do it for floats. Right, so if the type is not integer for variable a or b, then we raise one of the predefined errors, the type error, and because we don't want to do this specifically for variable a and b separately, we should just say that one of them is not an integer. And if they are integers, because this return statement is out of the indented block, we have a and b. So we could have result divide 3 and 5, and we get the result we expect. Or we can have a crash with a type error because we don't handle this exception, so we let the program crash, but we get the type error. So we have 3 as a string instead of an integer, and here we can see the traceback. Here we see our own defined error message, the exception we have raised, and we can see how this occurred, right? So we call this function, and then the error was raised, and because we didn't handle the exception here, the program then finally crashed anyway. So we would have a try and except clause around the statement here to prevent the crash. And this is what we do here. So if you want to avoid the crash, we can have the try clause, accept the type error, and then if everything works, we can have the result. But here we called the exceptions, and now we have another exception because the new result is only part of this indented block here, but it never worked because we crashed. So here the variable is not defined, right? So when we start with exception handling and making our code more resilient, we need to think about which variables are created where, how the functions and classes relate to each other, and what we need to cover. That does sound a bit complex, admittedly, but it makes our code much better and much more resilient and much less error prone if we construct our code accordingly. So we could do it like this. We could have result equals 0 by initializing a variable, have now the try except clause, and then print out the result. Now it's 0. Maybe this is not what we want, but then we would have to define a different way, or we could write that here the division didn't work and we need to handle the exception different way, but you get the idea. Right? We need, for example, we need to make sure that the default value is useful. We could also do the following. Here we have the division by 0. Remember from our earlier implementation that we haven't called this. So we accept the type error, and we call this exception, but we didn't handle the division by 0. So the program still crashes, right? So we've intercepted the type error, but not the division 0 error. So to make it even more resilient, we could do it like this. We have the default value, and we do the try statement. Now we have added the division by 0 error, and now the program no longer crashes, but we get back the default value. If we were not to use a Jupyter notebook but a Python code, we could also use the exit function, for example, here to exit gracefully if we think we cannot recover from this fate.